Hey children, this is your main girl Michelle Bonds here, better known as the math dealer.
Oh my gosh, the math dealer. I never thought I'd see one in person.
Whoa! Are you Pi because you are irrational? It's getting chilly out here. Y'all come into my math lab.
This is gonna be fun.
Welcome to this video of the Why of Math. Today we're talking about why of real numbers. We're going to start out with our positive and negative integers.
A good example of positive and negative numbers is when we're talking about temperatures. When we're here in Arkansas, our lows are usually in the positive teens or 20s, and it's not even a bad winter this year, so lows in the 30s. But there's a town in Russia that gets as cold as negative 22 degrees Fahrenheit. If we didn't have negative numbers, there would be no way to measure that. Hey, is that hot out here to anybody?
Another example of our positive and negative numbers is when we're using our bank accounts. If you have a deposit and your bills are less than your deposit, you come out with a positive balance. That makes everyone happy. However, if your deposit does not cover all of your bills, then you end up with a negative balance, and that definitely does not make anyone happy. So now we've talked about the positive and negative numbers, so now let's look at the other classification of numbers.
But why do we have to classify numbers?
Good question. Let's go. The reason why we classify numbers is just so that we can set them apart. The first numbers, for example, were simply created so that we could actually count objects. For example, there's one rose bush, two rose bushes, one piece of bark, two pieces of bark. Then it was decided, hey, how can we represent nothing? So then they put the zero in there. That became the whole number system. Then when you throw in the positive and negative, now you have a whole system of integers, which all fall under the category of the rational numbers. And in the real number system, you have both rational and irrational. This diagram shows the numbers classified in a real easy picture. We've already covered all the rational numbers. Now the irrational numbers are things like pi, things like fractions that don't have repeating decimals, or the decimals never end. Let's look at some examples of some irrational numbers. One of example is when we can figure out pi. Let's use this tire. Now if we look at the diameter, it's approximately 24 1/4. So then if we calculate that, we can actually come out with approximately 3.14. Here's the calculation. So we're looking at the circumference of 77 and the diameter of 24 1/2. So 77 divided by 24 1/2 is approximately 3.14. So a second example is using a standard size basketball. So if you have a diameter of 9.43 and a circumference of 29.625, when you divide those two, you get pi, 3.14. Another example would be a trash can. Here we have a standard trash can, diameter 15.825 inches, and then you have the circumference at 49.75 inches. We do that division, and once again, you come up with approximately 3.14. Remember, all of these calculations are approximate because as irrational number, it doesn't come out even. So you're eventually going to have to round to do the actual calculation.
But what about those square root things?
Another example of irrational numbers are radicals or square roots. As you can see here, you have a square. This square is actually 3 units on each side. So when you find the area of the square, it is 9 square units. But if we do it backwards, where you have 9 square units to try to figure out what is the length of each side, you have to do what's called square roots. In this case, the square root is actually rational because the square root of 9 comes out to the whole number 3. But look at this next example. In this example, you can see the square, if you look in the middle, actually is 2 units squared. Count them and see. So if we actually use that square root theory I was talking about, the sides are going to be the square root of 2. Put that in a calculator, you get an irrational number.